Hi viewers, good to have you here. Okay, this is E Plus Academic Resource Center where we take online tutorials from the graduates and senior secondary students. Alright, so today we're going to be looking at a very interesting topic under math. Okay, we're going to be looking at algebra. Okay, we're going to be looking at algebra. So we're going to be looking at algebraic expressions. Okay, algebraic substitution, simple operation in algebraic expression, then factorization of algebraic expression. Now, when we talk about algebra, what is algebra? Algebra is just a branch of mathematics where letters and numbers, okay, are used to represent quantities. Okay, for instance, if we say, okay, given an expression of a cost K, okay, K in naira of 10 books at S naira, okay? K in naira of 10 books, okay? At 10 books at X naira, okay? Each. And 5 pence, okay? At Y naira each, okay? Naira each. Find the costs when X, find the costs, okay, when X, okay, is equal to 3 and Y is equal to 2, okay. This is, we're talking about, remember I said algebra is when we use numbers and letters to represent quantities. So here we are talking about 10 books in X, at X each, and 5 pence at Y naira each. This should be at S naira, okay? S naira each, okay? So they are asking us to find the costs, okay? Express this whole scenario in the cost, what? K. Are we together? So now, if one book is equal to X naira, right? Okay? So 10 books will now be what? 10 books will be 10x. If one book costs X naira, then 10 books will be 10 times 1, which is 10x. Okay, 10 times this, which is 10x. Okay, then if 1 pen is equal to Y naira, then 5 pence will be equal to 5y. Okay. So our cost C will be equal to what? 10x plus 5y. Okay? And here we're given that x is equal to 3 and y is equal to 2. Okay? So here we have C is equal to 10. We substitute 3. Okay? Plus 5. Y is what? 2. Substitute. So C is equal to 10 times 3. 30 plus 2 times 5. 10. So C is equal to 30 plus 10, which is 40. Okay, this is a simple algebraic what? Expression. Are we together? Then let's move forward. Then we'll say, now if you check here, we substituted, we're given that x is equal to 3, y is equal to 2. So when we got to this cost function here, okay, we substituted 3 for x, then 2 for y to give us that result. That's a simple explanation of substitution. Okay. Okay. Now, what if I say x? Okay, x is equal to y plus z, and y. Let's say y is equal to 3 and z is equal to 8. Okay. X is equal to y plus z. So let's say y is equal to 3 and z is equal to 8. Okay, so in this case now all we have to do is we have been given the quantities for y, the quantity for z. Okay, so all we have to do is just to substitute these figures into the what? Letters. So s will now be equal to y here is 3, okay, plus z equal to what? Here z is equal to 8, so we'll just substitute 8. So x will now be equal to 3 plus 8, 11. So basically when we talk about substitution, it's when you have been given a value for a quantity, okay? That value when you have been given a value to represent an alphabet, y is equal to 3. That is to say, 3 is the same thing as y. So anywhere in the expression or anywhere in the equation that you see y, they are simply asking you to replace that alphabet with the what? The number or the quantity. Do you get it? So since y is equal to 3, anywhere you see y in your expression or in your equation, you substitute it. That is simply what we mean by substitution. So we are going to be seeing a lot of substitutions when we deal with, as we continue to deal with algebraic expression and equation. Do you get it? Okay. Now let's move forward. Now when we talk about simple algebraic expressions or operations, let's see. Let's say, for instance, we're asked to what? Expand x plus 4, okay? Close open brackets, 5 plus x, okay? Expand this, okay? Now, in this case, you will use what you have in the first bracket to open up the second bracket. Now, this is what we mean. X, open bracket, 5 plus what? X, close the bracket, plus 4. Open your bracket, 5 plus x. Now, you've used the first bracket to open up the second bracket. Now, the quantity is here. Now, for this expression here simply means this, what you have in this bracket, should be multiplied with what you have in the other bracket. That is what it simply means. So to enable us to multiply these two quantities, we open up the second one using the first bracket. We open up the second bracket using the quantities in the first bracket. Okay? So x times 5 will give us 5x plus x times s will give us s squared. Are we together? Then plus 4 times 5 will give us 20. Plus 4 times plus s will give us plus 4x. Are we together? So we have collect like terms here. We have 5x here, we have 4x here. So 5x plus 4x is 9x. So we have x squared plus 9x plus 20. Opening this bracket now gives us this expression. This quadratic expression. This is a quadratic expression. Let's look at another example. Expand 3x minus 2, open bracket, 2x plus 5. Okay? We'll apply the same method. We'll use what we have in the first bracket to open up what we have in the second bracket. So we have 3x, open your bracket, bring in this 2x plus 5, then minus 2, open your bracket, repeat the same thing you have, plus 5. Okay? So use this to multiply everything in the bracket. Use this one to multiply everything in the bracket. So 3x plus 2x, sorry, 3x times 2x will give us 6x squared. Okay? Plus 3x plus 5. 3x plus 5 will give us 8x. Minus 2x, minus 2, sorry, times 2x will give us minus 2 times 2 will give us minus 4x. Okay? Then minus 2 times plus 5 will give us minus 10. Are we together? So you collect like terms here. So we have 6x squared, okay, plus 8x minus 4x will give us 4x, okay, minus 10. So this is a quadratic what? Expression. So this is how you open up. These are simple operations in algebraic what? Expressions. So when you have brackets, when you have figures in brackets, two brackets, so you're simply asked to multiply what you have in the first bracket with the second bracket. All you have to do is use the quantities you have in the first bracket to open up the second bracket. Okay? Now this will lead us to what we call factorization of algebraic expressions. Now we are going to use these results we have here. Okay? We're going to use this result we have here to see how factorization works. That is the main emphasis, factorization. We are going to lay more emphasis on that because it's going to come in handy when we start dealing with method of solving quadratic equations. Okay, so let's see how factorization works. So with this figure, with these expressions we have here, we are going to solve We are going to factorize them to see our results, if they are going to give us the same result we had earlier. Are we together? All right, so let's see some factorization. Okay, factorization of algebraic expressions. Okay, now let's take some examples. Okay, now we have let's say we have 3d plus 5x plus 2d. Now when we talk about factorization, okay, what is going to happen is this. I will need you to understand factorization of algebraic expression before we move on to factorization of quadratic expression or quadratic equation. These are two different things. Algebraic expression is not the same with the quadratic expression or quadratic equation. What we have here is the quadratic expression because of the square here. Do you get it? Now, we are going to solve this later, but I need you to know this first before we can delve into this, into quadratic expression. We are not dealing with quadratic expressions and equations for now. Our focus is on algebraic expressions. So we want to know how to factorize some expressions before we delve into quadratic equation or expressions. Are we together? All right. So now in this case, when we talk about factorization, we are just trying to say factors. Factors simply means common characteristics in an expression. Something that is common in all variables. Something that is common. Okay? An alphabet that is common, or a number that is common in all in the whole of the expressions. Okay? Now, in this case, can we pinpoint a common alphabet or a common number or a common letter in this expression? Yes. We have D here, we have D here. We have, under this 3D, we have D here. In this case, we have 2D, we have D there. I mean here and here. Okay? So there's a common factor in this expression. Okay? So we have 3D, okay, and 2D. Now in this case, D here is a common factor. So if we are expressing these two cases now, if we are looking into these two cases now as factorization, we'll say 3 plus what? 2. Because there is a common factor in this between the 2D and 3D. Okay? So if we bring this out again, we have 3D plus 2D. Do you understand? But in this case, we have 5x here in the middle. Not just 2D and 3D. There is 5x here. So you cannot ignore this 5x. Are we together? Now, 3D and 2D. We have a common factor there, which is D. In other words, or alternatively, you can just say 3D plus 2D will give you 5D. Because there is D here, there is D here. If you were to ask, if you were given 3D plus 2D, normally 3D plus 2D will produce 5D, right? If you're asked to factorize this, you have D, open bracket, 3 plus 2. As simple as that. If you're asked to factorize this. But if you are asked to just solve directly, 3D plus 2D is simple as 5D. Do you get it? It's as simple as 5D. But in this case now, we are dealing with factorization. But we have a common factor between in 3D and 2D, which is D. So just go straight ahead. Add 3D plus 2D, which is 5D. Then plus what? This 5x. Now in this case, you have a common factor, which is 5. Okay? You bring it out, then D plus X. Do you get it? Let's look at another example. 7x minus 2xa. Okay, now you cannot do 7x minus 2xa directly because there is a different factor here. Let's assume there is no a here. 7x minus 2x will give you simply 5x. As simple as that. Or if you're asked to factorize 7x minus 2x, factorize. The common factor here is x. 7 minus 2, which is x. 7 minus 2 is what? 5. Which will also bring you back to 5x. Same thing here. If you're asked to, here now be d. 3 plus 2, which is 5. D times 5, which is 5d. Which brings you back to this. Okay? Which brings you back to this. But there is an a in the expression, a different factor entirely. So you cannot do you cannot deduct directly. You cannot solve directly because there's a different differentiating factor here, which is a. Okay? So all you have to do, there's a common factor here, x, and there's a common factor here, x. So you bring out the common factor, okay? Then 7 minus 2a. As simple as that. If you want to bring back this operation to its original position, 7 times x will give you 7x. Sorry, x times 7 will give you 7x minus x times minus 2a will give you minus 2xa. Which brings you back to your operations, your original operation. Okay, so that is how factorization works. Okay, that is how factorization works. You look for a common factor in the two expressions. Okay, let's take for instance we have 2xa plus 3xb plus 4xy. Yeah, let's take something like this for instance. If you check these variables here, this section and this section, these are three different sections. You check a common letter or a common number that is common. Okay, that is common in the three sections. That is common. Okay, let's take for instance this is 8. For instance, this is 8. Now there's a common factor here, a common number, which is what? 2, because 2 can go into 2, 2 can go into 8, and 2 can go into 4. So a common factor here is 2. Now you check the letters. There's a common factor here, x, because there's x here, and x here. So there's a common factor of 2x. In the 3, you must get a factor that is applicable to all sections. The factor must be applicable to all sections. Okay? Before you can bring it out in this manner. If it is applicable to only 2 sections, for instance, the factor should only affect the 2 sections and not the third one. So since this 2x now is affecting all the sections, that means we are going to factorize. The factorization must go through all the sections. So in this case now we have a plus 4b plus 2y. Do you get it? A plus 4b plus 2y. 2x times a will give you 2xa. 2x times 4b will give you 8xb. This is it. 2x times 2y will give you 2 times 2 is 4. xy. See xy. So the factor must cut across all sections. If it is not cutting across all sections, you only apply it to the sections it is affecting. Do you get it? Alright, so that is how factorization works. Okay, see how you can practice this. This is just elementary. Okay, it's not difficult. These are simple algebraic expressions, simple operations on algebraic expressions. So let's say 2xy minus 5xa plus 3x b. Okay, then we have 8a plus 16ab plus 5ay. Okay, so factorize this. Just practice it on your own. Okay, these are elementary operations in quadratic expression. Are we together? All right, we are going to stop here. Use the comment section if there's any area you don't understand, if there's any way you want to get clarification. Okay, this is basic for maybe JS3, SS1, even JS2. These are basic operations, but it is fundamental. Okay, it is critical when solving quadratic equation or expressions. It's very important. Okay, all right, thank you guys for staying to the end of the class. See you in the next class.